Hi, and welcome again to another Kontena online meetup. Today we're going to talk about a bit on load balancing and how Kontena manages and handles load balancing for the containerized applications that you are running on top of Kontena platform. Again, most of you probably seen me already on these online meetups or live meetups, and so my name is Jussi Nummelin. I'm one of the techies behind the Kontena team. I've been working on the industry for a good while already and really doing hands-on implementation and architecting and various things. Now working full-time on Kontena platform and its features. Enough about me. So load balancing is one of those things that's really essential on kind of getting right when you build your services in cloud environments, and especially if going towards microservice architectures or anything loosely coupled. So your services can easily talk to each other. You can scale out your individual services, and there are load balancers that handle both the internal traffic between services and of course also the external traffic that comes from your users to your applications. I think the term load balancing is of course quite known to most people in the industry, but essentially when we talk about load balancing, especially in this sort of a containerized environment, we basically mean balancing the incoming requests to a set of containers that are running your applications, your services. So basically distributing the workload for multiple resources, in this case containers. And of course, by having a solid load balancing solutions for your applications, you of course maximize the throughput and also minimize the response time for your users and other services that are consuming some other services. So what is Kontena Load Balancer then? It's basically a fully integrated load balancing solution within the Kontena container platform. What I mean by fully integrated is that Kontena really takes care of all the configuration for load balancing. You just, as a user, when you deploy services, you just add a couple of simple configurations to your service or stack YAML files. And after that, Kontena takes care of actually configuring the load balancing and replicating the load balancer configuration on the nodes and those sort of things. What it really then also allows is a really scalable solution, because you can run the load balancer itself on multiple different nodes. Thus your load balancer is highly available and also scalable. And of course that makes things really robust in a way that the load balancer is not tied to any infrastructure node or anything. So small failures for a node doesn't bring the whole system down. So some of the benefits, of course, is the full 100% automation that you get out of box with Kontena Load Balancer. As said, you define a couple of simple configurations on your stack YAML files, and after that Kontena takes care of managing the load balancing, configuring it and making sure things work properly. What you also get is elasticity, because whenever you scale your services up and down, whenever something changes in your services, your containers, the Kontena Load Balancer is always automatically updated and reconfigured in a minimal downtime fashion, so that the configuration always follows your service configuration. availability comes pretty much out of box for the load balancing itself, as the load balancer can be running on multiple different nodes with the exact same configuration. So it doesn't matter where the external request hits, on which node it hits the load balancer. The load balancer will always have the proper configuration available. And of course, it means also availability from your application point of view, because the load balancer is basically distributing the traffic to multiple instances, multiple containers of your application. So if one of those containers crashes, for example, and the load balancer will see that it stops responding to requests and basically takes that out from the circulation, so to say. And of course, as in any serious load balancing solution, Kontena Load Balancer is of course able to do SSL termination also. What it means is that you don't have to configure things like certificates anymore on your application level, because it's not really your application concern to configure any certificates for SSL termination. It's really up to the load balancing layer to do that. And of course, zero downtime deployments from the applications connected to the load balancer. And zero downtime in this case really means that zero downtime as long as the load balancer itself is not redeployed, and to the extent that HA proxy, the underlying technology, kind of gives us. So it's pretty close to zero in normal cases. I kind of gave it away already. So internally, the Kontena Load Balancer, the sort of main component and the actual workhorse is HA proxy. And as many know, HA proxy is one of those things that are really widely used in the different solutions. For example, GitHub utilizes heavily on HA proxy, and a bunch of others also. So it's really battle tested and proven technology in the load balancing scene. Of course, to be able to have everything configured and controlled automatically, we sort of sprinkle something on top of HA proxy. So currently we use a component called confd to automatically generate the HA proxy configurations. And the sort of backend for the load balancing configurations is the etcd key value store, which we have running on each of the container grids. So etcd, as it's already available on the grids and all the grid nodes, it's a natural place where we actually store and kind of with etcd we are able to replicate the load balancing configuration for all the nodes. So it doesn't really matter on which node the HA proxy instances are running or the load balancer containers are running. It's always able to sync up the configuration from the etcd key value store. And then of course some other sprinkles of bits and pieces that really create these highly efficient, highly available and really easily usable load balancing solution. So from the automation point of view, the load balancer and its configuration is really fully managed by Kontena platform. And the service instances, essentially containers, they are always dynamically attached and detached as they come and go on the grid environment. So the load balancer really keeps up on the environment and on top of the different containers and service instances. Also, the service level configuration, the load balancing algorithms and those sort of things, they are always dynamically updated also on the load balancer. So the load balancer really kind of watches the configuration changes and as needed it reloads the configuration and then reloads it, the working processes. Also, as I already mentioned, the load balancer itself can be scaled up and all the configurations automatically replicate between the nodes. And it's also possible to deploy multiple different load balancers for different use cases if that's needed. And also, on the other hand, it's really possible to have one single load balancer service that actually handles traffic and balancing for multiple different backend applications. So either way, it's kind of a many-to-many relationship. I think it's quite usual actually to have even multiple load balancers running on a given grid environment, because the load balancer can be also used internally within the grid between the different services that are running there. The load balancer is quite flexible to deploy. I mean, it's as you'll see in the demos. It's although it's fully managed by Kontena platform and the configuration is managed by Kontena platform, but then again it's still kind of just another service that you deploy. So as it's just another service, you can use these different deployment strategies like daemon set and those sort of things, or you can define different affinity rules so that only some of the nodes in your grid environment will be running the load balancer. So it means that you don't actually have to expose all the nodes to internet, for example. Just expose a couple of nodes and run the load balancer there. Also, it's flexible from the service configuration point of view. So all the load balancing configuration for your services are defined in your stack YAMLs for the different services themselves. So when you deploy a new service and want that to be behind the load balancer, you don't actually go and change the deployment and the configuration of the load balancer service itself. You just add the link and couple of Kontena load balancer environment variables for your service that you're running and deploying. And with those, the load balancer gets automatically configured. So it's really easy for you to change the different configurations for different services, and really you don't need to touch the load balancer configuration and deployment at all. There's a couple of kind of common patterns that we've seen with Kontena load balancer and of course use ourselves. So as I already mentioned, it's good pattern to have separate load balancer for internal and external purposes. And with external, I mean things like getting traffic from the internet, from the external network, and then of course internal meaning balancing the traffic between your services running within the grid. Also, it's quite common to see the load balancer deployed only to some of the nodes, then which nodes are then exposed to internet or whatever public network your service is serving. Also, as the load balancer is just another service, it of course uses the deployment strategies and affinity rules. So for example, I could run the load balancer with the daemon strategy, which makes Kontena to deploy the load balancer to each of the nodes. But then if I specify also affinity rules to follow label exposed, it means that there is always going to be one instance of the load balancer running on all the nodes that are labeled as exposed. So it gives you quite a good flexibility on the deployment of the load balancer itself. I think that's kind of enough for the sort of theoretical part, and as always, it's best, things are best explained with good examples. So I have quite a few different demos that I'm gonna show how to utilize the Kontena load balancer for different cases, and hopefully give good examples on how to utilize the load balancer. So for the demos, I have a couple of different use cases. First one is the sort of typical web application load balancing, again with the boring to-do web application. Then I'm going to show an example on how the path-based routing works on the load balancer. Then one example on internal load balancing, where actually a stack that's installed brings its own load balancer, and that also uses some custom status check, kind of cool hacks, so to say. And then I'm gonna quickly show how the load balancer itself can already actually exposes some statistics to see how the load balancing works and what it's actually doing. So for the first use case for the web app, it's the typical to-do web app demo that we've used in quite a few of the online meetups. So basically what I'm going to configure is and deploy is the web application with the 3 web frontends. I'm going to do a virtual host configuration so that there is a domain name that gets routed to these web containers. I'm going to enable SSL termination so that the load balancer actually terminates the SSL traffic for me. And then I'm going to show how to even force HTTPS to be used on the client side. Okay, so enough on the slides, and I'll switch to the terminal. So as usual, I have my demo environment up and running. I have quite a few nodes running, and as seen on the labels, they're actually kind of all around the world. So running on different cloud providers. And let's first see about the load balancer itself. So as said, the load balancer itself is just another service on Kontena Grid. So what makes it special is the image itself. So Kontena actually recognizes based on the image that, okay, this is a load balancer, and then provides sort of a bit extra love and care for the load balancer service. In this example, I've deployed the load balancer using the demo strategy. And so basically there's a load balancer running on all the nodes connected to my grid at the moment. And of course, to be really able to demonstrate that things work as expected, the load balancer is exposing the 80 and 443 ports so that I can actually get traffic into the load balancer from the internet. So I have already deployed the load balancer. So if I go and check the service, So the stack name was infra, and the load balancer was external, LB external. Show, yep. So we can see that it's actually running on quite a few different instances, as the daemon strategy says that it should be running. So first the web application. So this is the usual to-do web app backed up by MongoDB database. So what I have in the stack file, I have of course the MongoDB. Today is not about the Mongo, so let's skip the Mongo part. Then I have the web application. I have of course 3 instances running, or I want to have 3 instances running because I want my application to be highly available. There's a link to the infra/lb external service, which then triggers the ongoing automatic configuration of the load balancing for this service. So the link to some load balancer really triggers the sort of magic to happen on the Kontena platform. As usual, some configuration through environment variables, and also the Kontena load balancing configuration can be fine-tuned and configured through the environment variables. So there's quite a few different Kontena LB starting environment variables, all of course documented on the documentation, which then configure how the load balancing itself happens. So in this example, as promised, there's a domain name that's mapped to this web application. So I've configured it with the Kontena LB virtual hosts to be to-do-demo.kontena.io. Another thing that's configured in this example is the internal port, because the application that I'm spinning up, it's a Ruby application running on top of the Puma server. So and it listens on 9292 port. So as it's not using the standard HTTP 80 port, I have to tell to the load balancer basically that okay, when proxying traffic, use the 9292 port for the containers. And that's really it. There's 3 or 4 lines of configuration that's kind of makes the load balancing really happen and makes the magic happen. So it's really simple from the typical cases for the end user and the service point of view. And of course, if I go to my browser now and hit the to-do-app.kontena.io, I get the typical 503 response that service is unavailable. And well, of course it's unavailable because it's not deployed yet at all. So stack not deploy, install to-do.yaml file. And now the Kontena CLI tool gives the YAML to the Kontena master, and then master starts to spin up the services on the different nodes. And now basically the CLI is just waiting to see that all the services, in this case the MongoDB and the web application, gets deployed. One of the things that happen during the deployment process is that when Kontena sees that this service is actually linked to a load balancer, then the Kontena agent on the node is able to and then puts all the needed configurations into local etcd key value store. And as etcd is highly available and replicated. So automatically all the configuration replicates to all of the nodes running on the cluster. And then basically the load balancer then of course pulls the changes on the etcd and then reconfigures itself whenever there are changes that require reconfiguring things. So the deployment is hopefully soon done. The MongoDB is already deployed, and the web application should be deployed in a minute or so. It's always the first deployment of the stack that takes a bit longer than other deployments, because there's quite a lot of images to be pulled. Okay, so everything deployed successfully as expected. So now when I refresh my browser, the load balancing should pick up things in a second or so. What? Did I misconfigure something? To do demo Kontena IO? No, everything should be okay. What? Unexpected demo effect. Interesting, to say the least. Let's check one of the load balancers and yep. My browser isn't working for some reason. Let's try the incognito mode if there's some cache or something. Yep, seemed to be some browser caching thingy or something. Okay, so the load balancing really happens, and on the lower part of the screen there's a footer that shows that which of the container instances actually served the traffic or served the request. So now if I refresh my web page, it's a bit slow to respond, but it's automatically doing a round robin balancing as the default. So as you see from the YAML and from the service configuration point of view, it's pretty straightforward to put a load balanced application and deploy that on top of Kontena platform and then connect it to the Kontena load balancer also. A couple of other examples that I have prepared is the virtual hosts. So I can have not only the routing can be done also on the path base. So in this example, I link things to the external load balancer, and then give different virtual paths that a web request with this path in the URL should go to the Nginx service, and then with the Apache path should go to the HTTP service. And then, of course, let's deploy that. Stack install v Why did I? Yeah, okay. Yes. The stack is pretty badly named, but it should be virtual path, but never mind that. Yep. Both the Nginx and the Apache have been deployed. So now if I again hit the load balancer with an IP address and a path, and how did I configure those? Nginx and Apache. Nginx. Oh crap. Something wrong in my load balancer itself. It's not probable. Let's see. Or maybe I've actually misconfigured some of the IP addresses for the DNSs. Oh yeah, that's probably it. Kontena stack service show infra lb external. No, crap. I hammered today quite heavily the different configuration options, so maybe I've misconfigured something on the load balancer itself. So let's see if it starts to behave. No. Let's upgrade the load balancer if it makes it work better. While waiting for the load balancer deployment to finish, what I actually deployed is the new version of the infra stack, which then contains also the certificates for the SSL termination. So I have actually two different certificates configured in my secrets vault, and the load balancer then picks up those and is able to terminate the SSL on two different domain names. Yes, load balancer deployed again, and I still get service unavailable. That's really weird. This turned to be more like a debugging exercise now than a really good demos. Seems that the load balancer itself is properly up and running. I probably have some weird configuration that I've made in my environment. Okay. Let's see if any other, or maybe the problem is only on some of the nodes that are not able to handle the traffic properly. No, it's the load balancer that's keep giving me a hard time now. Let's remove some of the stacks that I might have misconfigured things on. Give it a kind of fresh start. Yep. Fresh install for the load balancer itself. And while that's deploying, I'm gonna show another neat trick to force in some custom settings on the load balancer. So as said, we do have quite a few of these different ready-made Kontena load balancer environment variables that control specific things on the load balancing, such as the domain names and balancing algorithm and things like that. And but we also support this sort of a more flexible custom settings environment variable, which basically means that as the underlying technology in the load balancer is HA proxy. So with the custom settings, you can basically inject any HA proxy configuration through your service YAML. In this example, I put a redirect if the connection is not SSL connection. The load balancer then automatically redirects the request to a HTTPS URL. So basically forcing your browser clients to connect through HTTPS to your service. Yep. Load balancer again deployed. And then install the to-do SSL, for example. It's again the same to-do application, but just with the different LB setting for the redirect thing. Again, as I completely removed the to-do app, the deployment takes a few minutes and while it spins up MongoDB and then deploys all the web containers that are needed. Yep. And hopefully it really works now. Connecting. What? Today is not the day for my demos, it seems. Is my network really working? Should be. Why is it so difficult today? Okay, let's grab an IP address of some random load balancer instance. Yep, that should give 503 as expected. Okay, then I'm going to do a local because I think I've actually misconfigured the domain name, the DNS record somehow. So I'll do a local faking on the to-do demo. Yep, now it works. So it's probably my misconfiguration on the DNS part that's causing all the troubles. So as you saw, it automatically now redirected me to a HTTPS site, which is pretty cool with a one line of configuration on the service level. Then one example on how to utilize the load balancer within a stack and within a grid. So this is actually based. This example is based on the Matti/Redis Sentinel stack on the Kontena stack registry. So I just made a few tweaks and added a couple of comments and a couple of different variables. But essentially, the point of this example is to show that you can deploy the load balancer as part of your stack also, and in this case, it exposes a port out basically to the internet, and as the comment says, it's really just for testing purposes. So it's easier to test that the deployment really works. The stack actually sets up a Redis in a clustered manner with the Redis Sentinel. So there's a bunch of Redis nodes running, and each of them connected with the TCP mode on the load balancing. So the Kontena Load Balancer can really do also TCP load balancing. In this example, the trick is the custom settings again. So in the Redis Sentinel setup, the client should always be connecting to the instance that is the master in the Redis cluster, so to say. So we do it actually on the load balancer level. So the load balancer gets configured now with the custom setting to do a really custom live checks with all the container instances. So it basically connects on TCP. It sends the typical Redis ping command, expects a pong back. If it gets pong back, and then it queries the replication info. It expects to see a role master, and only for the nodes that are responding with the master role info, they could actually they are part of the replication. Sorry, not replication, but the load balancing. So all the other nodes that are not replying with the master role, they're actually considered being down from the HA proxy and from the load balancer point of view. Thus, they will not get any traffic. So it's actually handy trick to make sure all your connections to your Redis Sentinel cluster goes through to the master node. Kontena stack install Redis Sentinel YAML. Ooh. Line 15, I've made some mistake somewhere. Yep. So I've added a couple of variables that prompt me some deployment strategy for the load balancer. I'll select the highly available balancer. How many instances of the load balancer I want to be running within the stack? Well, let's say 2. And now it deploys the different services in the Redis Sentinel stack. again takes a while to pull the images as the stack hasn't been running on this grid. As you can see, in the Redis Sentinel stack, there are some Matti's images. Matti is the guy who wrote the original Sentinel stack. I just tweaked it a bit, so kudos to Matti for that. Should be deployed in a minute or so. Yep, less than a minute. So now if I go and service show, I'm lazy, so I'll copy paste Redis Sentinel /lb. So that's the load balancer service within the Redis Sentinel stack. So I want to find a public IP address of one of those load balancers, and as there is the standard Redis port is published there, so I can actually do a Redis CLI minus host. Or was it ho? I mean minus h. Now what was the option? Minus host, yeah. Oh, bloody hell. Now I remember why things don't work always as expected. I don't have the Redis port open on the Amazon side, so let's grab this one. This looks like a DigitalOcean IP address. So probably I should be putting an affinity rule for the deployment of the load balancer in that example. Yes. So as you can see, I can do the normal typical Redis stuff on the Redis CLI. Those were only few examples how to utilize the Kontena Load Balancer. Of course, as mentioned, there's quite a few different options available how to configure how the load balancing happens on the services, and all those options you of course find on the official Kontena documentation. I still want to share a couple of things from the slides. So, of course, we do have future plans also for the load balancer itself, and one of the things we've been working on is actually kind of almost rewriting the configuration management on the load balancer. So, as I said, it's currently based on confd and confd's ability to create the actual HA proxy configuration on the fly based on a template. But as we all know that templating languages and templating systems, they're nice and pretty easy to use, but they are quite limited. And we've been starting to hit the confd templating limits recently, and we're actually planning to kind of rewrite the whole configuration generation and the whole configuration management of that. Other thing that we've been planning and having some proof of concept level work already is some sort of a support for canary deployments, blue-green deployments, and those sort of things, so that you could actually deploy kind of multiple versions of your web application, for example, and then have some proportion of the load distributed to this new version of your application. Also, we've been thinking of implementing some of weight-based controls also, so that you could create different weighing for different instances on different infrastructure and those sort of things. Also, the metrics, which I actually forgot to show, which I will in a few seconds. So the metrics is something that we've been thinking on improving also, so that it would be possible to see the load balancing metrics and statistics on the Kontena cloud side also, because that's one really key metric to see when you're running your services and providing services on the network. So how the statistics can be accessed currently is basically through through the VPN. So I'll open a VPN connection to my grid. Yep. Oh, why does this pop up always? So again, I'll check the infra load balancer. I just grab the DNS name and go to my browser. So internally within the overlay network, and thus accessible only through the VPN connection, on a port 1000, it's basically serving a status and statistics page. So the normal HA proxy statistics page. Why does it work? DNS address. The DNS keeps failing me today. Let's go with an IP address. Yep. And if of course the authentication is configurable, but the defaults are something easy to remember as stats and secret. So I can see the statistics of a load balancer. Of course, there's not much traffic going on my service because it's not going viral in the Twitter yet, but hopefully soon. But anyway, we are thinking and planning to export at least some of these statistics on the Kontena cloud side also in a fancy way. How to get started with Kontena? Well, of course, sign up to the cloud.kontena.io, install the CLI tools, then spin up your Kontena master on your favorite cloud provider, spin up your nodes and enjoy the ride. Of course, if any trouble, join the Kontena Slack, community Slack. So there's a bunch of like-minded people hanging around there, asking questions, answering, giving help and guidance. So thank you for joining the online meetup, and hopefully we'll see you soon on the next upcoming meetups. Thanks for watching and enjoy using and utilizing the Kontena platform on your solutions. Bye.